Dear friends and colleagues, welcome back to the Mangano Digital Academy. In the last lecture, we have considered the topic of intraoral scanner. In particular, we have talked about the trueness and the precision of the intraoral scanner. But there's another thing that we must talk about because it's very important, and we are talking about the resolution of acquisition, because very often colleagues make confusion about this concept, and it's anyway it's very key and very simple, and everybody needs to understand it properly because it's important for our workflow. So what is the resolution of acquisition of an intraoral scan? What is the resolution of an intraoral scan? Because the resolution of acquisition should refer to the scanner itself. Let's go back to the basics. An intraoral scanner emits a light source, laser or structured light, on the teeth surface and captures its modification to powerful cameras. The collected data then used to calculate the spatial coordinate of each point at its surface. Powerful 3D reconstruction software generates point clouds that are then triangulated into meshes by means of interpolation. So this is how the scanner works. And this is how the polygonal mesh is built. We have a point cloud, so the structured light grid with this known geometric property, the scanner knows everything about it, is projected onto the object, in this case the dentate maxilla of our patient, the object to be scanned. This grid undergoes deformation. This deformation is captured by the cameras and sent to the software. The software is the brain of the scanner, so it's the most important part of the scanner, much more than the cameras. The cameras are usually very powerful. They have a high resolution of acquisition, but they are not the only determinant. They are not the only key factor in determining the resolution of acquisition of a model, because then the software comes. The software is the brain. The software elaborates a point cloud, and based on this, then there's interpolation and there's mesh construction. So a set of triangles is built connecting this point, the selected point of the clouds, by means of interpolation, by means of algorithm for the reconstruction. And then we have the reconstruction of the external surface of the scanned object. So we have a surface reconstruction that is represented in this case by the mesh and by the standard tessellation language file. It's important to say that the polygonal mesh is the reconstruction of the surface of the scanned object, and it comes from a point cloud. Then we have an interpolation, and we have a set of triangles. Then we have a surface that is made by 1,000 million of triangles, and it's very important, depending by the different machine, of course. And the definition of mesh is this one. Mesh is a collection of triangular, contiguous, non-overlapping faces, joined together along their edges. A mesh contains vertices, edges, and faces. It is sometimes also called a triangulated irregular network because we use triangles, but of course we can have mesh also with polygons, not only triangles, but usually we use triangle because it's easier to render this kind of surface and to reconstruct this kind of surface by means of triangles using different kind of reconstruction algorithm. Then we have our 3D model. So this is the mesh. And what is the resolution? When we talk about resolution, first of all, as I told you, for the trueness, as I told you, the precision, we better refer to the mesh itself, and not we should not refer to the scanner itself, because of course the scanner plays a role, but the software is the most important thing. So we better refer to the mesh. Why? Because the 3D model of surface reconstruction of the scanned object, the mesh, can have more or less triangle based on the decision of the software. So basically, the final resolution of a mesh depends not only by the scanner, of course, that the point clouds, then the decision made by the software, but not only by the cameras of the scanner, let me say, but also and mainly depends by the software. So we have two key players here, the cameras, but almost all intraoral scanners, they have high resolution of acquisition, they have powerful cameras. And then I have the software. The software is the second, but the most important key element, the heart of the machine, because there are algorithms, because there are 3D reconstruction algorithms, because the software determines the mesh, and so the quality of the mesh, and so the number of triangles inside the meshes. So the resolution of 3D models What is the resolution of 3D model? Resolution of 3D reconstructed model is the number of faces of triangles that compose the mesh. So we have a resolution of acquisition given by the different cameras that the intraoral scanner has, and usually intraoral scanners are equipped with very powerful cameras. They collect a lot of information, they send this information to the software, then it's the software that makes really the difference, because the software can decide to pick up more or less points and then to generate more or less triangles. And then we can have a resolution of acquisition that can be lower or higher, depending by the choice of the software. And let me say that the resolution of acquisition has almost nothing to do with the trueness. So we are talking about something different. Even if I have thousands, hundreds of thousands of triangles, I can have a model that is completely untrue. So there's no correlation between trueness and resolution of acquisition. Anyway, resolution of acquisition is very important for a series of reasons. And let me say that in our work, the best way is to have a resolution of a mesh that is adaptive. So the tessellation should be finer with a denser sampling only in the areas where we need, where it's necessary. For example, on the margin line of a prepared tooth, natural tooth, because it's more important to see well there. We need more triangle, we need to have a mesh that is denser there. The tessellation should be finer there. And but on the wall of the abutment it is less important. We can have even less triangle and even, bigger triangle. So it's very important to have an adaptive resolution. Anyway, when we go from the point cloud to the polygonal surface, to the mesh, to the triangles, we have basically 4 steps that we can consider. We need to remember a pre-processing, a downsampling. So points are sampled to reduce the input redundancy and computation time. So there's a sort of data elimination, noise reduction, the outliers are rejected, the holes are filled, so there's a pre-processing. And in this case, then there's the determination of the global topology of the object that is also quite tricky, because we are talking about an object that the scanner doesn't know. Then we have the interpolation, that is also point 2, and we generate a polygonal surface based on triangles. And then we have a post-processing. Post-processing is very important because we have a series of editing operations applied to refine and perfect the surface. So edge correction, new triangle insertion, editing, and all these steps are only performed by the software, so they depend by the 3D reconstruction software only, and the interpolation is very important. So what we find after the object is recognized, after the pre-processing the object is recognized, we have this transformation from a point cloud to a mesh that is called interpolation, and it's very important. It's probably the most important part of the handled by the software. So basically what happens that these points are joined together, the points that make the point cloud, they are joined together to form the scanned object, the mesh. The process brings from a point cloud to the final mesh, and it's called interpolation. And of course the software is the key element in this. And of course we need to remember that it's a sort of approximation, but the mesh is always an approximation of the surface of the real object. Anyway, it's very important to have an approximation that is true, precise, and also, if possible, to have an adequate resolution of acquisition in order to discriminate among different structures. That is very important. Interpolation is difficult, I have to say, and it's also important to consider that different scanners, they have different technology for the acquisition of 3D images, and they have different algorithms, and all these algorithms are proprietary algorithms, and there's a competition among the different producers, of course, and it's very important to say that there are differences among the different machines. Once again, I can say that a good sample should be dense in detailed areas and sparse in featureless parts, so adaptive. But the input data need to satisfy the properties required by the algorithm, of course, because otherwise we can have incorrect incorrect results. So the resolution, when we talk about resolution, we should talk about the mesh, of course, because the software can decide, for example, to have a different resolution for the same acquisition, if we need more or less triangle. And we should not refer to the scanner itself, because the cameras are usually very powerful for all the scanner. The software is key. And so the final resolution of a mesh depends not only by the intraoral scanner used, but also by the parameters selected for the acquisition in the software. So we can have, for example, the same software can generate raw resolution, medium resolution, and high resolution images. Like here, for example, in the scan flow from Carestream Dental, when we have acquired our 3D models, the master model, the antagonist, and the occlusion, then we need to refine the model, and we have to choose among low, a medium, and a high resolution. And there's a huge difference between these three options, and it's the software that asks us what do we want to do, because if you are working, for example, with orthodontic model, maybe we don't need such a high resolution. But if we are working, for example, in prosto with a model with prepared teeth, then it's key to have a very high resolution, because we can send this model to the dental technician, and the dental technician can better discriminate the margin line, because the dental technician need to write in a computer assisted design software, need to draw the margin line, and they need to see the margin line, otherwise it's not possible to draw it correctly. And if you have more triangle, then you have a better visibility and distinctness of this margin line. So as we can see here, same model reconstructed by the same software of the scan flow from Carestream Dental, we can have very different meshes. For example, with a low resolution, I can have less than 70,000 faces. With a mid resolution, I can have a little bit less than 150,000. With a high resolution, I can have even more than 300,000 triangles. It makes all the difference for our application. So it's very important to consider and to pick up the proper application and to choose the proper balance, because we need to choose for our clinical purposes. Cameras and software. So when we talk about resolution, we need to talk about cameras and software. The cameras of the scanner are important, as they need to have a high resolution of acquisition, but the 3D model that is processed is above all the results of the reconstruction software and the interpolation algorithms. So the big difference, the game changer, is the software. The algorithm makes the difference. It is particularly important to focus the attention on the most important points. So the margin lines in the preparation of teeth, particularly natural teeth, because with implants it's less important to have such a high resolution of acquisition. With the natural teeth is even more important, and because the mesh should be dense enough exactly where the margin line is, because it has been demonstrated by several researchers, particularly by Robert Nedelko and colleagues in a very beautiful paper published in BMC Oral Health a few years ago. They demonstrated that the clarity of the margin line changed in relation of the resolution of acquisition. So if the resolution of acquisition is higher, for the dental technician it's easier to see the margin line, and therefore to draw the margin line and the closure of the future restoration better. So it's important to thicken the mesh in that area, to have an adaptive mesh that is denser exactly where it's needed. But of course, once again, I repeat, a denser mesh does not mean necessarily higher accuracy, because resolution and accuracy, they are not the same thing. As we can see here, in a low resolution with less than 90,000 triangle for this full maxilla, we can see that the STL file is not so beautiful to look at. But if we need to print it for ortho purposes or for diagnostic purposes, for diagnostic model, then it's an option, because we don't need to have so many triangles. If we have another application, for example, if we need to, for example, design a surgical guide, then we can use a medium resolution with less than 200,000 triangles. We have enough triangle to design our surgical guide on, and the guide will fit perfectly, will be enough precise, and we don't need to have so many triangles, because more triangle, the file become more heavy. And then we have, for prost application, almost 400,000 triangles. Here we have a very, very dense mesh with a lot of triangles. The resolution of acquisition of this model, is very high because of the software. I mean, the cameras play a role, but the software is most important, because with the same software we can choose different level of resolution of acquisition and number of triangles, as we can see here. And clearly, visually, it's much more beautiful to watch a model that is rich in triangles, because it looks more detailed, but it's not necessarily needed to choose all time the high resolution protocol, because it's not needed. Sometimes for ortho purposes, for example, the resolution is more than sufficient. And the resolution is not trueness. In principle, scans with high density, so with a higher resolution, can be converted more easily into a faithful digital image of reality, while those with a lower density, with a lower resolution, can introduce error due to the lack of digital information between them, which will cause dimensional defects, non-existent curvature, discontinuity. But there's a big but. A scanner could produce meshes with a very dense point cloud, and these do not necessarily correspond to the actual points of the surface of the physical model. In fact, there is no relationship between resolution of acquisition, resolution, and accuracy. Accuracy in terms of trueness and precision. A lot of studies have been published recently, and from my experience also I can tell you that for some implant application, for example, there's no need to have such a high resolution. The most important thing is the trueness, because trueness is even more important. And a lot of paper basically found that there is no relationship between the accuracy of a model and the resolution of the model itself. And also, I mentioned it before, this very important paper by Nedelko and colleague, published in 2018 in BMC Oral Health. They found that if the resolution of acquisition is high enough, adaptively, it's much better for the dental technician, because the dental technician can better visualize the margin line and then draw the margin of the restoration better without making any error. High finishing line distinctness was more related to high localized finish line resolution and non-uniform tessellation than to high overall resolution. So once again, adaptive resolution is the solution. It's better to have an adaptive resolutions. Topography variation were low, and also the color sometimes could help the dental technician to identify the margin line. In some software, we can have also the possibility to save the file, the output, into a polygon format that is an STL plus color, and this is not a real color, but it can help a little bit the dental technician. So once again, the concept of adaptive resolution is important. The resolution of a mesh should be adaptive, with a finer tessellation where necessary. In principle, where the curvature of the mesh is higher, more triangles are needed. Where the mesh is flat, less triangles are needed. Once again, the critical area is the area of the margin line of the prepared teeth, because here denser mesh is highly recommended in order to gather more data and to transfer the data to the dental technician that need in the computer-assisted design software to draw the margin line. It's key. It's very important in order not to make error, mistakes, and not introduce mismatches. And here we can see it clearly. If we watch this mesh, that is why, it's already very dense mesh, but if we watch the preparation, we see that many more triangles are, located in the area of the preparation, because here we want to have a denser mesh that is highly recommended to help the dental technician to identify the margin line, and it works very well. So several machines have this option for the adaptive resolution. Of course, artificial intelligence is working fast and well, but still the operator usually need to identify manually this area, and then the software recognize this area as the area that should be, more carefully reconstructed with more triangles. So thank you very much for your kind attention, and if you have some questions, some criticisms, some doubts, please don't forget to write me here. I'll be happy to reply to you and to try to answer to all your questions and criticisms. Thank you very much, and bye-bye.